Let's talk about something that might not seem exciting at first, but it's absolutely vital to keeping an irrigation system running smoothly: the wire. Whether you're powering the controller, connecting valves, or splicing wires in the field, how you handle irrigation wire makes all the difference in system performance and reliability. I'm Dr. Denise DeBusk, and in this section, we'll break down the different types of wire you'll use, how to choose the right one, how to install it safely and effectively, and, most importantly, how to protect your splices from water and weather damage. We'll also look at why certain common practices are risky and what to do instead. This is the kind of practical knowledge that keeps systems running and callbacks to a minimum. Before we get into wire sizes or splicing techniques, let's start by clarifying the difference between primary and secondary wiring, because this is where safety and legality come into play. Primary wiring is your high voltage line, 120 volts or more, and anything on that side has to be handled by a licensed electrician. That includes breaker panels, pump panels, and power wiring into controllers or pump relays. You can't touch this as an irrigation tech unless you have the right license. What we can work on is the secondary wiring, which is typically 24 volts AC. This is what controls your valves and most decoder-based systems. Florida law makes it clear we can only legally work on circuits that are 30 volts AC or less. So when you're planning your wire routing or troubleshooting, it's essential to know which side of the system you're working on and when to call in an electrician. Primary wiring is what delivers the line voltage, basically the high power, to your irrigation controller, pump, start relay, or pump. Most systems use 110 to 130 volts, but bigger pumps might use 220 or even 480 volts. There are two main ways to connect a controller: hardwired directly into power, or with a pigtail that plugs into a grounded outlet. I prefer the pigtail. It's safer and easier to disconnect. Just make sure the pigtail is rated SJTW and no longer than 6 feet. If it's outside, it must be plugged into a GFCI outlet with a full-time weatherproof cover. And remember, any work involving line voltage must be done by a licensed electrician. It's not just about following code, it's about safety. Now let's talk about secondary wiring. This is the low voltage wiring that runs from the controller to valves and sensors. It's usually under 30 volts, and it's what we're referring to when we say irrigation wire. You've got a few types to recognize. There's single conductor, just one insulated wire, and multi-conductor, which has several wires inside a protective jacket. That jacket might have a little nylon ripcord to help you peel it open. Wires also come as solid or stranded. Solid means one thick wire strand. It's stiff but good for the common wire. Stranded is flexible and found on valve solenoids or sometimes lighting systems. Then you've got decoder cable. That's two color-coded wires inside a thicker jacket, sometimes twisted inside to help with signal integrity. The key here is matching the right wire type to your system, especially when it comes to sensor compatibility and signal strength. Let's talk about the wire we're actually using out in the field. First off, not all wire is created equal. For valve wiring, it has to be UL rated and safe for burial. So look for markings like UF, direct bury, or sprinkler wire. Don't try to get away with using thermostat wire, speaker wire, or anything that's not meant for soil. That's just asking for trouble. Now, about wire gauge. The lower the number, the thicker the wire. Most systems use 18 gauge or thicker, and you might see the common wire in a larger gauge to help prevent voltage loss over longer runs. For color coding, the irrigation industry follows some clear standards. White for the common, red for valves, and spares are often blue. Just avoid using black or green as singles. They're reserved for high voltage and ground in electrical work, and that can get confusing fast. Let's wrap up with insulation and how systems are usually laid out. Wire insulation matters. Polyethylene is the way to go. It's durable and colors stay vibrant over time. PVC insulation fades, cracks, and eventually turns gray in the sun. For system layouts, most setups are either single conductor or multi-conductor. With single conductor, you'll often have all red valve wires and a white common. It works great, just make sure you're using waterproof connectors at every splice. With multi-conductor wire, You'll get a bundle of different colored wires. Makes it easier to keep things organized, especially on bigger systems. Just like with single conductor, waterproofing those connections is key. Let's be honest, every wire splice is a potential failure point. That's why the quality of your splice really matters. You want a splice that does two things really well. Keeps the wires from pulling apart and keeps water out. The two main conductor types are a sealant-filled wire nut and a wire nut inside a sealant-filled tube. The tube version is better. It gives you more contact area with sealant and extra strain relief. The wires are gripped inside the tube, not just twisted together. That makes a huge difference, especially underground. Now let me save you some classic bad habits. I've seen it all. Tape jobs, glue, sealant blobs inside a cheap wire nut. None of that holds up underground. What you want are modern, waterproof connectors. Some don't even require stripping the wires, just insert and squeeze. These newer connectors have sealant and piercing blades built in, and they're great for valve splices. They grab the wire, make a solid connection, and seal it tight. Bottom line, better materials, better workmanship equals fewer callbacks and happier clients. If you're going to splice, do it right the first time. These are the key steps. Use connectors designed for direct burial, no exceptions. Strip your wires carefully. You don't want to nick the copper because that weakens the conductor. If the connector requires it, twist the wires tight. Don't just jam them in. Insert them all the way into the connector and make sure the sealant surrounds the insulation, not just the copper. Look for connectors that provide a watertight seal and offer strain relief. This keeps the splice strong even with movement or moisture. And always give it a gentle tug to make sure it's solid before you bury it. A little extra care here goes a long way toward avoiding future failures underground. So here's the bottom line. Know the difference between primary and secondary wiring and treat line voltage with the respective demands. Pick the right type of wire rated for burial and pay attention to colors and gauge. Don't just grab what's cheapest or convenient. And when it comes to splices, they're the most vulnerable spot in the system. That's why using the right connectors and following the best practices can save you a ton of time, money, and callbacks later. Wire it right, and your irrigation system will thank you for it.